Okay, so here we are solving this ramp problem for the second time. This time we're doing it with a coordinate system. Okay, so we're breaking the forces down into perpendicular components. We've chosen x to go this way and y to go that way. Okay, so now we get to sum the x forces, and all the forces acting along this line have to add up to 0 because forces acting along this line can't help us cancel out a force along this line unless we have force at angles, but we don't. We've broken it down so we only have forces going up and down, or this one and this one. So we've replaced this one that's at an angle to our coordinates. So let's look at the sum. Let's use a different color here. Let's look at the sum of the forces in the x direction, which have to all come out to be 0. So we have FF, that's acting sort of up. So FF, and that's acting sort of this way. So I'm going to make that way positive. So I've decided to make that a positive force. And then we have FGX, which is acting this way, so we'll make that negative. So we have minus FGX because it's acting the opposite direction, and they have to sum up to 0. Okay, so I'm not, just showing you these are acting in opposite directions, so I've used a convention and given them opposite signs. There we go. So, simple way of writing this would be the magnitude of FF has got to be the same as the magnitude of FGX. Okay, so that's an equation that we get from summing the forces in the x direction. Okay, so now let's go and maybe sum the forces in the y direction. Okay, so we have this force right here, Fn, acting directly up. Remember, y is an angle like this. So we have Fn acting directly up, and I think we should make that positive because that's just very familiar. Up is positive. Okay, and now we have FGY acting down, so minus FGY. So those two have to cancel each other out. This is acting down, right, which is y. I decided to make it negative. This is up, so it's positive. So we get that Fn is equal to FGY. Okay, so I have two equations to work with here. This one from summing the forces in the y direction, and this one from summing forces in the x direction. Okay. Now, I just want to remember what the point of this whole question was. It was to find the coefficient of friction. So neither of these forces neither of these equations that I have here have the coefficient of friction in them. So what am I going to do? Oh, I'm going to remember that FF, okay, remember that FF equals mu Fn. Oops, let's not remember. Okay, let's remember that FF is equal to mu Fn. So instead of writing FF in this equation, I'm going to put mu Fn equals FGX. Okay, and I'll just show it right here. We'll just rewrite it. So this was FF equals FGX. This was from the x direction. And what we did here is we just subbed this in for FF. So this really is still just from our x equation. Okay, now we're going to bring out the equation from the y direction. So we've got FF, this one, equals FGY. Okay, so now what if we take this and divide it by that, then the FNs will cancel out. So we're going to go mu Fn is fgx, and Fn is fgy. So now we get mu is equal to fgx over fgy. But fgx is equal to fg times the sine of 30 degrees. That's fg times the sine of 30. fgy is equal to fg times the cos of 30. So now the fg's cancel out. So we get to get rid of this and this, and we have sine 30 over cos 30, which is the same as tan 30. There we go. Mu equals tan 30. Slightly more complicated, lots of substituting, but that's working with an x and y coordinate at an angle like this, instead of just adding the forces tip to tail. So maybe this convinces you, you might like to think about adding forces tip to tail. Okay, one place we could step off and make things a little bit simpler for ourselves is right here. Okay, instead of making this substitution, we could look, hey, wait, this is a side right here in this triangle. This is the side that is opposite our 30-degree angle. And this is a side that is adjacent to our 30-degree angle. So actually what we're looking at is opposite over adjacent, which is equal to the tangent of that angle. Okay, hope that helped. Sure is a lot more work than adding the vectors tip to tail. Okay, good luck.